Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Supercharge your AI pipeline by fine-tuning transformer models. A deep dive into concepts and code. Before we dive into this particular discussion, I want to show you what is going to be the output. Let us go to the browser. If you guys are new to this entire large language model concepts, artificial intelligence related domain, then I would suggest that take a look at my various playlists and also especially this video on AutoTrain, where I discuss how the fine tuning is done automated, in fact, by the Huggingface Hub AutoTrain service. The key challenge in case of the AutoTrain is it does not right now support text generation activity, meaning it does not support the text generation task. So what does this mean? So let me go to this is one of the models that has been already fine-tuned by me, but not fully fine-tuned. So this has been partially fine-tuned, where I give it a huge blog or a post or a essay, and when I hit compute, so it's a pretty long essay, and once I hit compute, the model loads and it gives the tags that can go with along with this essay. So what I mean by the tags, let me go to the example. So here is an example of the dataset that I've used. It is called medium articles. This particular dataset was created by Fabio. The link of the medium article along with the dataset, Kaggle dataset, will be shared in the YouTube description. A huge thanks to Fabio. This particular data you see is the text that you see here, and this text has this tags. And the target of this particular discussion is to create these tags from these text. So this is a kind of multiple activity that needs to go through this model. So it has to, first of all, the model has to understand what is there in this text, and it has to then convert it into number of tags that this text can have, and these tags should be related with this text. How is the model going to learn all this stuff? Let us go to the here. This is the page that I was loading an example. Sorry about that. This is the page where I was loading the example, and you see the output is coming very similar to the tag. So it is still wrong. It is saying chatbot. It's just repeating whatever this particular text is talking about. So it's talking about chatbots. So it is repeating it. The idea is to create or fine-tune the model in such a way that it can properly locate the tags and provide it as a output. So that is the target. For doing this, we have to use fine-tuning. So you have to give a text to a model, and the model will give the output like this. So basically, we are going to understand a couple of things here. So we are going to understand how this data is represented by the model, by the transformers architecture, by the Python ecosystem, and then how the model is getting trained and how the model is going to give this output. So this is the target or the objective of this discussion. For this, we need to, as I already explained, we need to enlist support of lots of information, not just because this is a team endeavor, but this is an open source endeavor. So lots of open source technologies comes into picture. Among those technologies, Huggingface Hub and the transformers library from Huggingface Hub is the key player in this. And we will be working extensively with Huggingface Hub. So ensure that you have already got an account in Huggingface Hub. If not, sign up, and then you will be able to access this model also, and you will be able to access this particular dataset also directly. So finally, this is the overall setup that I'm talking about, and the code with respect to this particular notebook is already shared. This particular video is already shared in the GitHub repo. This particular link also will be shared with you guys. With all that said, let us get back to the presentation. So sorry about the disturbance. Let us get back to the presentation. But I have given you the setup, right? But what am I talking about here? It's all about, some kind of matrices and numbers. What is all these things? The data is represented as numbers, and these numbers are placed inside matrix, and that matrix is what the Python ecosystem or the training library in transformers that I will be introducing in a couple of minutes will work upon. So this is the raw material on which the model and the training of that model will happen. The raw material comes in various formats. So here, this particular set you see is actually a classification data. So this is an example. This particular sentence, "this is nice," is a good kind of a positive sentence. So this will be classified as good. Same way, when you take a look at this particular sentence inside the transformers architecture, that is Python ecosystem, it will be in form of numbers 28, 57, and 86. So this numbers, how it is getting converted, is not something that you need to be really caring about. Okay, all you need to know is that, okay, the word "this," the word "is," the word "nice" will be represented as numbers, and that numbers will be inside a matrix, like the matrix is here. Matrix is nothing but numbers that are having rows and columns. Why am I simplifying a very complicated topic to this level? Because at the end of the day, all the complexities that goes into this topic is not going to really help us to understand what we want. So that is why I'm trying to simplify it as much as possible. Okay, you will understand why I'm doing this in a couple of minutes. This is the classification data that I was talking about. So this second row, this row is the number for some other English statement. This row is for some other English statement, and this number 1 talks about the statement could be negative or it could be neutral. So all these things will be properly encoded. And the point I want to make here is this is actually very simple. So you will see how to create the model for doing this classification in the next step. I will come to this later. I will come to this step later. So how is the model represented? Okay, first of all, what is a model? Model is simply an equation. Model is simply a formula that which actually tells, okay, you take the first number, second number, third number, multiply with some other numbers, and you'll get the output. So the some other numbers, the x, y, the c, these some other numbers are exactly the models. So you see A, B, and C, that is also represented as a single matrix, is the actual model. So once you have this data with you, and also once you have this data, that is the output, you can take these both data and send it through this model and make the model to learn it. Okay, what is model learning? Basically what happens is, the first row, when the model learning starts, the entire data that is available with us is fed into this equation, and the output of each of this data point is verified. We already know the correct output, right? We already have the data with us. So we will verify it with the correct output data, and we will see the difference, and the difference is the loss. So when the model is getting trained, the difference between the correct and the predicted output is reduced continuously. So that is called as training. That is all you guys have to learn about training and model fine-tuning. That is all. You don't need to worry about how it is being done, what algorithm is being used. No, it's not required. All you need to really understand is that if I am going to give it a sentence, after doing the training, if I am going to give it a sentence to this model, the model will be able to classify whether the sentence is good, bad, or neutral without any issues. Yes, the model will not be perfectly accurate. There will be cases where the model will predict wrong. For that, we have a different model, different idea. That is where the neural network comes into picture. So here, this particular model is simple single column matrix like A, B, and C. Now think about a matrix which is not just single column. It is going to be multiple columns. So here you see A1, B1, C1, and also like this there will be multiple other columns in this same matrix, And same way, there will be multiple matrix which goes on at the back in 3D. So that is neural network. And when you are going to create a neural network like that, the model becomes a three-dimensional or multi-dimensional matrix which can store not just the information. It can store the structure of the sentence that you provided or the text that you provided, or in fact all the data that you have in this world currently, we can actually represent it as numbers by using whether it is text, audio, video, image, you name it. It can be made into numbers by using various modules called as tokenizers or encoders. You convert it to numbers and you feed those numbers to this model. The model will learn by realigning all these parameters, and then it will be able to predict the output. So what is output here? For an example, when I talk about a little more complex activity, it is generating sentence. So I give a partial sentence like this is nice. This is a partial sentence, and I want the model to generate what comes next. That is, I want it to generate warm and cozy. How is this going to be possible? It can be possible if the model knows that after the word nice, the word warm will come. The model has to learn this. And basically what the model has to learn is after 86, number 7 will come. And like this, there is going to be a lot of data. And like this also, we are going to have a lot of data. And we are going to feed both of this into this neural network, and the neural network will learn. Once the neural network learns, what will happen is all the parameters inside this neural network, that is A1, B1, A1, B1, B2, C3, C4. I mean, the parameters can be in billions. So that is the major difference. Like the parameter, when the model is having a lot of parameters, the model can actually learn a lot of information about the input data. It can learn about the structure. It can learn about the functions that is inbuilt into this structure. It can learn about the emergent behavior, meaning it can learn about the first sentence and the last sentence. So a lot of, the first part of the sentence and the last part of the sentence. So it can store the structure of the input data. That is how the large language models have been created. So why am I talking about the neural network right now? So let us go back to the browser and let us take a look at the output. So here I'm going to give such a big raw data, and I'm expecting it to come out into a structure like this. So it's a structure basically. It's a structure of a list of text. I want the model to learn from this basic input that it has to create the list of outputs. And I want the model to learn about the important points in these inputs and create that as list of outputs. This is what I want, and the model can do it. How the model can do it? If we provide a lot of data points of the input along with the output. So let us go back to the browser. Let me show you. So this particular article you see here, it has 190,000 plus rows of text and their respective tags. We are going to feed both of this into the model, into this model, and we are going to make it learn. And you might be wondering, Kamal, who is going to create this model? How this model will come into picture? This is the next step that we have to learn. Okay, and you will be surprised that you don't need to do a lot of any of the works, because let us go to the next step. So here I am talking about what and how of fine tuning. Here I am explaining what is a fine tuning. So it is retraining the neural net that is already trained for a particular task. So this is called as pre-training, and with a new set of input data and labels, so it can learn the new information. What I'm trying to say here is that you don't need to create this neural network. It is already created by the researchers or the existing developers or ML engineers. All you need to do is take one of these models that is already available and then tune it in such a way that it can do your task. That is called as fine tuning. The immediate question that comes to your mind is, where will I get the neural network and how to get hold of it? That is where Huggingface Hub comes into picture. Huggingface Hub stores 206 plus models of open source category inside the Huggingface Hub. You read it right. It is 206 models, and each of these models can do different tasks. Each of these models have been tuned or pre-trained on various data sets, and all the information regarding the models are available in the model card inside the Huggingface Hub. In this particular discussion, we are going to use FineTuning model, and I'll be discussing about that particular model in a couple of minutes. Okay, so if you go through this, if you have gone through this particular slide, you would have seen the first step is deciding the task and the neural net that needs to be trained. Then you have to study, and then you have to create the data set. So these are the three steps we need to do, right? We already know the task, right? So I already showed you the task that we need to perform. That we need to create this structure output, list output from this input. So basically, this is the raw material. The model will act as a tool. It will act as a die. If you guys are from the manufacturing background, or if you guys have seen in your home, if your mom or if your wife is making any of those sweets, you see they will put it inside a die, or in fact chocolate. So you guys have seen Cadbury chocolate, right? It comes in certain shape, certain size. So how is that happening? It is happening because of the die. So model is like a die, and the die is generated automatically by using the data. And the model becomes a die in such a way that when the new data is pushed into this, or new text is pushed into this die, the output comes in the way we want. So this is a very easy way to visualize, right? So you take this entire raw data and you push it into this model. So I will show you the files. It is raw files actually. So you push that models into that file, and the output is basically the structure that you want. So these are the raw files, and once the data is pushed into this bin file, the structure of the output is shown like this. Now this is what we want. So the structure of the output is like this. So it comes out like this, and the entire slide actually explains about these things only. Okay, I believe you like this content. Do leave a like and share it with others, and subscribe to my channel to discuss upon not just large language models. I discuss upon various topics related to open source and also the libraries that is surrounding Python. Now let us continue further. So I have given you the brief. I have spoken to you about how the model is represented, how the data is represented, and what happens in neural network when it is getting trained, how the model can be thought of as a manufacturing die, which can take the raw material and it can provide the output in the way you want, the text output in the way you want. So think about ChatGPT or Google's Bard. Basically, what these models are very big parameter models. 175 billion in case of ChatGPT, or GPT-4 is a little bit higher. I heard it was 250 or 264 billion. And in case of Bard, it is 540 billion. I mean, these guys are really, really huge, and they can do a lot of tasks. And now what you are doing is, in case of our target, we are only doing one task. We are not doing hundreds of tasks. All you are doing is, we are taking this raw data, we are asking the model to convert it into this particular structure. You are not asking the model to do a lot of things. You don't want the model to create CSV file. You don't want the model to create the SQL code or Python code. No, all you need the model to learn is that just take this data, convert it into important points and make it into list. And for doing this, you don't need a very big model. You can actually work with very small model, and we are going to use T5. FineTuning is a very small model compared to other models. The parameters are in millions. I think it is around 200 to 500 million in between. It's not that big, and this model can learn a lot of stuff, and it is really, really helpful when you have to do sequence to sequence modeling. That is sequence. This is a sequence. This is nice. This is one sequence, and warm and cozy is another sequence. So if you want to model sequence to sequence, then you have to use T5. You can use T5. There are various other open source models that are really good, but they are huge. Like for an example, GPT Neo or Llama or Alpaca, you name it. All those models have been fine-tuned on base models. Like the pre-trained models, they take that, they feed it new data, new input and new output, and then they make new models. That is how it is getting done. But there are lots of algorithms, there are lots of ways to get the data set, there are lots of ways to feed the data into the model. I mean, a lot of research and work needs to be done. And that's the next step. So how to do the research, right? If you are, as I'm explaining these things in detail, I'm going into this step, but actually you don't need to do the research. If you go to any of the blogs or any of the videos like this, you will be directly told that, okay, you can use FLAN-T5 or you can use GPT Neo or you can use some other model, and all the necessary code, etc. will be shared to you guys. All you need to do is, as I always say, that you have to, yeah, you heard me right, practice. Why you need to practice is the next step. So here I am telling that I want the output to be like this. Maybe you don't like this output. You want the output to be in form of a CSV file, or you want the output to be in form of table, and you want to convert all the information into table. So how are you going to do that? That is where a little tricky step comes. So what you can do is, you can take this data, you can hit any of the large language models with this data, and you can ask that large language model to create the structure that you want. Okay, so again I'm repeating. So you take this raw data, or let us go to the browser. That will be easier for you to explain, for me to explain. So I told there is 192k rows, right? So out of this you take some 10,000 rows. You don't need to take all the 192,000 rows. Take some 10,000 rows and take all the text, feed it to the large language model of your choice, which you already have access to, and then make it to create the structure that you want. So here the structure is in form of tags, but if you want this to be converted to table, if you want to convert it into CSV file or JSON file or whatever file it could be, so you can actually make it to convert. Let me do that in front of you so that it will be easier for you to understand what I'm trying to say. I'm going to use BARD, and be really careful about this. Once the data actually hits the particular large language model through their API or through their service like this, then the service will know that you have used this data. You are used to create the new data using this service. So if you are going to use the output, so let me complete this activity. So it will be easier for me to explain in that way. I'm going to take this data. I'm instructing that convert the above data into table containing concepts and explanation column. Okay, so I'm going to hit enter, and let me see what kind of generation it creates. So I'm showing you how to create the data set. So you see here, so it is creating the concept and it is creating the explanation. So it is creating a structure, and this particular structure, what you see here, is created by symbols. So if you go here, and if you actually take a look at the raw data of this this particular table, you will see it is made of only text. So you can create you can, for all this 10,000 or 20,000 row you decide, you can create this kind of structure, and then you can create new data set. So it will have the text and this kind of structure in this place, and you can then feed that into the model. You understood what I'm trying to say? So instead of this structure, it will have your structure that you want, and you can feed it in the model. And once you feed it and once you fine tune the model, then the new fine tuned model will be able to create the structure that you want when you give the new input. This is the whole point of fine tuning. And some people call it instruction tuning, some people simply call it as training, but whatever you call it, what is happening inside is more important. What is happening inside? It is actually helping the model to learn the structure. and all you are asking the model to learn is only one task. You are not asking the model to learn all the tasks available. You are only asking the model to learn one task. So basically, model not only learns the task, it learns the structure of the data, it learns the information inside the data, and all these things it stores as numbers. And all these things are possible because the way the numbers are stored. If it is a simple matrix like how I have shown it here, I am 100% sure that you will not be able to get the output like how you are getting it in BART. That's not going to be possible. The way the model is getting stored is extremely complex. It is called as transformers architecture, which in itself is a new introduction that was done in 2017. It has both encoder and decoder details, encoder and decoder module. You can get all this information inside the Huggingface Hub. If you go to docs and if you visit the transformers documentation, so you can get all the information regarding the models as well as their understanding of the. So if you go here, if you scroll down, you can see that they explain a lot of things about the, just a minute, conceptual guides. So here they explain to you everything. So they explain to you what is tokenizers, they explain to you what transformers can do, what is transformers, how it is being done. All these things are explained. Apart from that, they also tell you the various models that is available. So each of these models you can research from here. As I was explaining in the PDF quite some time back, that you need to choose the model, right? For choosing the model, where will you go? You have to go to the Huggingface Hub. And in order to do the research, you have to go through this slide. I'm not going to explain anything from this slide right now. So all these things, if you go to the browser, go to the transformers documentation, you can get all the information regarding the model. So who actually created the model, who designed it, how they developed it, what kind of data set is used, and how to use this data set. All this are provided, including the examples. Everything is provided. So for an example, if I want to work with FlanTFi, if I click on FlanTFi and if I wait for it to load, it will explain to you everything. Why FlanTFi was created, what is the data set, how to use it. Everything is provided. So you don't need to really think about, okay, how to learn about the model or how to create the model. So it is all done for you guys. Only thing is you need to know how to use it. And most importantly, you have to know what kind of challenge or what kind of output you are looking for. Once that is known, then it is about, it's all about once you decide the task and once you know what is output, then you have to make the data set, and then you have to choose the model and train the model. And once you train the model, you have to check the output. So that I showed you in the beginning. By going to the browser, I showed you in the beginning, right? In this place where we showed the inference endpoint. So that is the overall step that you need to do. So this is how you check it. So yeah, that's all about fine tuning. So that is all we have to learn. We can close this video, right? But no, we are not going to close this video because we are actually going to do a fine tuning task. And as I was telling you, the task that we are going to do is we are going to take the text and we are going to create tags. So that is the task we are going to do. And we already have this Medium article created by Fabio, which already has the tags. So I don't need to create it. I actually showed you the BART example just for you guys to understand what is going on. But in this case, I'm using the existing data that is available to me. So let us go to the code. We already understood how the data looks and how the output. Sorry, excuse me. So we already have seen how the data looks and how the output looks. Next, we have already seen what is the model that we need to choose. That is, we have already decided we need to go with FineTuning model. Next step we need to decide is how we are going to feed the data into the model. This depends on the model to model. Okay, so before doing that, this is the Jupyter notebook that we will be using for this particular discussion. This code is already shared, as I told you. All you need to do is just run this code. The point where you need to show concentration is that when we are going to tokenize the data. So you see here I am creating something called as a prefix called create tags. So this create tags will be attached to this text. So in the beginning of the text I will be attaching create tags, and then in the label, if you see, I will be giving the tags label. So the input will be this entire text along with create tags. Output will be the tags alone. So this particular tags alone, you saw it here, this particular tags alone. Both of these will be tokenized and then it will be sent into the model. So this is the tokenized data that you see here. So all these things, if once you execute this particular code, you will be able to see this. And if you are going to change the data also, you can actually change the data. Only thing is you need to ensure that the data is in this form. So it should be in text and it should have the output here. The tags is the column name that you see here, and the text is the column name that you will see here. You see the text column name. So that is what I'm using. So most important point in this code is to understand how the data is fed. So that is what I'm explaining to you here. Once you understand that, you can actually fine tune with your own data with your own task. That also you can do. You can actually try it out. That is one of the practice that you can work on. But in order to change any of this, I would suggest that first of all execute it with this particular code only. Don't change anything. You need to have GPU for executing this code. Ensure that you have GPU enabled. So if you go to this, you can manage the runtime and you can get it done, get the GPU. T5 is a small model, so it can run in the GPU also, should not be a problem. So once you tokenize it, next step is that all this information, which kind of class to use, how to write the configuration, how to get the training arguments, all this has been taken care by the T5 documentation. If you read it, you will get to know that. And also they give a lot of, Google researchers have given a lot of example notebooks that you can review and you can find this out. Fabio, person who had actually created this notebook, had given all this information. I'm just reusing it. Only thing is Fabio had done the fine tuning for getting the title, but I am doing it for getting the tags. So that is the only difference. And you see, once the arguments are set, the next step you need to do is you need to set the evaluation. In the beginning, I explained to you that the model needs to compare between the original and the prediction. So let us go to the PDF. In the starting of the process, I explained that the model will predict new data and it will compare with the already existing data, and it will see the difference, right? And that is called loss. But in case of sequence to sequence, that is text to text conversion, model has to check word by word. So for that, there is a different metric called as Rouge, and that is implemented. So the point is, I'm not actually going deep into the implementation of all these things. You have to understand the steps that is taken, but not the implementation, because the implementation can change tomorrow because it got abstracted, but the overall steps are going to be same. Even if you are going to use auto train in the future, if auto train creates the text generation text generation service, even then internally auto train will do all these things. So you need to understand that even if you are going to use automated process, you need to still know that what task you want. You need to decide what task you want. You need to feed the data set. So AutoTrain cannot create the data set. You have to feed the data set. And then these two steps can get automated. But making the data set, deciding the task, deciding the model is all done by you. To a certain extent, AutoTrain tries to choose the model also, but I would suggest that understand the various details that you need to learn about the model and choose the model when you are going to do the task. There are 206 models, so you don't need to learn everything. That if you go to the internet and do a research for a particular task, you will be told that which model is good. And in case of the task that I am right now targeting, FineTuning is good. So that is how this entire process goes on. I hope that you guys have got a gist of what is going on in the backend. And after you let us go back to the code. So now I am doing this evaluation is fixed, and then I have to create the trainer instance. So this is how you create the trainer instance, and after that you have to just call trainer.train method, and the training starts. It is as simple as that. Once the training has completed up to 2500 steps, and the model has got pushed to the hub. And you can save the model, you can reload the model inside the Google Colab environment, and you can do the inference. So you see the code, this code for that. And also you can push it to the hub using this code here. So these are all the various steps that I want you guys to understand. So in this particular discussion, we have understood not just the fine tuning, we have understood the core concepts of data representation, model representation, neural net representation, and how the model, the neural net, the ChatGPT, Bard like models convert themselves into a kind of a die from which they can manufacture lots of data. So this is the key point. You guys have to keep it in your mind. You have to visualize in your mind that whenever you want a particular structure out of the particular text, then you need to visualize that, okay, there needs to be a lot of input and output text fed into the model will learn, and then once it learns sufficiently, then it will be able to generate the text in the way you want. But it is going to take a lot of training activity, and training is going to take huge amount of resources. So keep that in mind. The particular notebook I was explaining provides free GPU. So this notebook, Colab Notebooks, provides free T4 GPU for 12 hours in a day. So you can use that. It's one of the good services. Keep one thing in mind: when you are going to execute these for your own purposes, or whether you are going to put it into production, you need to do the due diligence of how are you getting the data, who is the owner of the data, who is the owner of the model. All these things you have to do the due diligence and ensure that all the ownership related discussions, license related discussions are taken care. Okay, most of the discussion that I am having is about open source models, but the data set may not be open source. Like this Medium article data set is not open source, right? It is written by many authors, and these authors may or may not allow you to use their data. Anyway, we are using their data for learning purpose. We are not going to use it in any commercial settings, and we are going to take any profit from that. We are learning, and later we are going to keep the model for future reference. We may not actually put it in production. But if you are going to put it in production, then you will know that this particular data and this particular structure that you are planning will be based on your data, your own data. And when you are going to send these data into APIs like Bard API or OpenAI API, keep that in mind that the OpenAI server or the Bard server or any of the LLM server will be able to look at your data. They may not be storing the data, but they will be still looking at the data, and their model will get the knowledge. So that is something that you guys have to keep in your mind when you are thinking about these things. So with all that said, I believe that you have got some good detail about how to do the training of the fine tuning of the model, what is required for fine tuning of the model, and how to check the output. I believe that you have learned a thing or two from this video. Do leave a like and share. Sorry about the disturbance that is happening in this video, because there is a storm brewing around, so that's why you see that, hear that noise. Sorry about that. With that said, I would like to leave this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.